So let's get started. So today I'll begin with a problem here. So this is from the book, exercise 5.5, complete the timing diagram. Okay, this kind of diagram is, by the way, called timing diagram, okay? So this diagram is called timing diagram for a D flip-flop. So this is the D flip-flop, which is which works with the negative trigger. So how do you represent negative trigger? Trigger is a triangle here, right? When it is negative, you have a circle here outside. That means this is negative, this is trigger. Okay, negative trigger. Meaning, what is the meaning of negative trigger? It operates at the low going edge of the enable input. Meaning when it's from high to low, okay, right at this moment, it transfers the data. Okay, that's the meaning. So let's so we are supposed to find Q. Okay, we are supposed to find Q. Given D and E, how to find Q? Okay, that's the thing. So now look at the we have to start with the E, right? We start with the E. So negative, negative, right? So 1, 2, 0. When the trigger goes from high to low, right? High to low, right? At this point, the data transfer, right? That's the meaning. So where is the high to low here? So this is low to high, then high to low is right here, right? This is the high to low. And this is high to low, right? This is high to low. 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 And this is high to low. Oops. This is high to low, and this is high to low. We just worry about these locations here, okay? So nothing else. Right here. So at this location, what happens? That's what we are trying to figure out. So now the data is low in the beginning. So it remains low. Okay. Data is low, it remains low. Now right here, not even here, right here, right at this point, right? Right at this point, there is a transition from low to high, sorry, high to low, right? At this transition, what happens is it takes the data. At this transition, what is the data? At this transition, is the data low or high? Can you help me here? At this moment, is the data high or low?
High.
High. That's why you have high here. See? You have high. Then, until this point, it remains high. Okay? Then right here, is the data low or high?
High.
High. This is high, right? That's why, again, the data remains high until this transition here. At this transition, is the data low or high?
Low.
So that's why it goes low up to this point. At this transition, is the data low or high?
Low.
So that's why it remains low until the other transition. At this transition, is the data low or high?
High.
High. That's why now it is high up to here. At this transition, data low or high? High. That's why it remains high again. At this transition, data is again high. Again remains high up to this point. At this transition, data is high. That's why it remains high again. That's it. That's how this works. Okay. Question here, please. Okay, if there is no question, then let me move to the next slide here. The next one is JK and T flip-flops. First of all, we'll do the JK flip-flop. Okay. So this is, the JK is named after the scientist, Jack Kilby. So JK, right? He's the Nobel Prize winner in physics in 2000. Okay, so JK, so that's the name of the flip-flop, first and last name. So he invented this flip-flop, and we name it JK flip-flop. We just named S, remember we had the SR flip-flop, right? So SR, right? So the S is now, we modify SR flip-flop. Okay, that's the whole idea. We modify SR flip-flop and we call it JK flip-flop. Okay, that's the whole idea. So that the modified version, this S is J. Okay, in the modified version, S is J and R is K. Okay. So why do we need to modify SR flip-flop? Okay, that's the main reason behind the modification. So what is the reason behind it? The reason is in SR flip-flop, remember your S equals R equals 1 is a problem, right? That's illegal, right? S equals R equals 1 is illegal. So to avoid that, JK flip-flop was developed, okay? So it means in JK flip-flop, S equals R equals 1 is not a problem anymore. All right. So as I said earlier, so S is J, right? S is J, and R is K. R is K. So this is the JK flip-flop. This is the NAND version of the JK flip-flop. What happens is, so this is familiar to you, right? This guy is familiar to you, this section. This section is no longer new to you. This part, right? This is very familiar. Now, this Q is connected to, so you have two more NAND gates here. I call it NAND gate 1 and NAND gate 2. I call it G1 and I call it G2. Okay, gate 1 and gate 2. So there is a gate 1 connected to gate 3 like this. And there is a gate 2 connected to gate 4 like this. Okay, and also, so this Q is connected to gate 2. See that? Q is connected to gate 2. And also Q bar is connected to gate 1. Then there is a clock, okay? There is a clock. This is the enable signal, right? Clock. So this clock is connected to both G1 and G2 like this. And you have the input J and you have the input K here. That completes the JK flip-flop. Question here. So far, so good. Okay. Now let's see how the JK flip-flop works. So this is the symbol of the JK flip-flop, by the way. So this is the more detailed version, but this is just a symbol. Okay, we call it graphical symbol, by the way. This kind of symbol is called graphical symbol. So you have the positive edge, right? This is positive edge trigger. So JK flip-flop works when the clock goes from low to high. When the clock goes from low to high, JK flip-flop works. So that means it's a positive trigger, right? So clock is connected here at the positive trigger, it works. That's the meaning. Then you have J, the input, and K also the input. You have Q and Q bar, the output. Okay, this is the JK flip-flop. which is called the graphical symbol of JK flip-flop. So in the NAND version of the SR flip-flop, so what happens is if S equals 0, R, actually S prime, right? I meant to say S prime, R prime. So S prime is 0, R prime is 0, then it is in the previous, it is a hold state, right? The 0 and 1 set, 1 and 0, 0, 1 and 1, this is illegal. Okay, that's the thing. Now, let's see how this works. Now, let me begin with the S equals 0, R equals 0 in the case of JK flip-flop. In other words, J equals 0, K equals 0, right? Okay, so this J is 0, this K is 0. Right, so what happens is, then what is the, so what is the input of G1 and G2? So what is the output of G1 and G2, sorry? What is the output of this guy? Can anybody help me, please? What is this guy here?
0.
Excuse me?
0.
This is an AND gate, right?
So 1.
1. Right? So this is an AND gate. So whenever there is 0, one of the 0 in the input, right? If 0 is there in the input, that 0 determines the output is 1. So right. There is 1, so there is 0, there is 0. No doubt this gives you 1, this gives you 1. Okay? Now, so what is the, this is QT, by the way, okay? This is called QT. This is QT, this is QT bar, okay? Now, we need to find QT, this guy, we need to find QT. How do you find, so what is the, so what is this guy? What is the output? Sorry, what is the input of this guy? Can I say, before QT, what is the output here? Before QT, what is the output here? QT minus 1. Okay, so before QT, you had QT minus 1 here. Before QT bar, you had QT minus 1 bar here. Now your goal is to figure out QT, right? To figure out QT. To figure out QT, you have to rely on the previous state, right? QT is the final state. QT minus 1 is the previous state. QT bar is the final state here. QT minus 1 bar is the initial state here. This is final, this is initial. This is final, this is initial state. Now, to figure out final, what do you need? You need the initial state, right? Okay, so this is 1. Let me go here. This is 1. So what is the input here? Can you help me? Is this initial or final? So let me ask you a question. Now in this case, is QT bar the input or QT minus 1 bar the input?
QT bar.
Yes, I know. So this is this input is coming from here, right? Okay. So at this location, you have 2 output here. One is the final output, the other one is initial output, right? So we are going to find the final based on initial. So based on T minus 1, you are going to find T. Okay. So what is your output here? That goes here, so that we can figure out QT. To figure out QT, what should be used here? Do you have to use QT bar or QT minus 1 bar? Guys, did I ask the question clearly? Or
Is it -1 bar because that's the initial on that side?
yes. So this QT minus 1 bar goes here, right? Then it gives me the final. When you have final QT here, then what is the final here?
QT
QT
bar.
bar. That's the thing. Does it make sense?
Yeah.
Okay, good. So that's why this guy is QT minus 1 bar. Okay. Now what is the output here now? What is the output? So how do you find the output here? So what is the NAND gate? How does the NAND gate work? If you have A and B, 2 input, how does the NAND gate work? A, B bar, right? That's the table for the, that's the formula for the NAND gate, right? So it means, so what is your A here? 1. So what is your B here? So what is this multiplied this? Right?
Mm.
So what do you get here then? QT minus 1. That's what it is. Does it make sense? Guys, question here, please.
So how do we go from this to a 0 or 1 value?
That's a very good question. Okay, that's a very good question. I'll go there. Okay, so let me explain this first, then I'll go there. That's a very good question. That's $1 million question. Thank you. So now similarly, what is your QT bar here? So what is the input? So how do you find the QT bar? Do you take which one is 1, right? One of the input is 1 here. What is this input? You are trying to find QT bar. That's why your input is QT minus 1, right? Your input is QT minus 1. So this guy is QT minus 1. QT minus 1. So 1 and QT minus 1. 1 and QT minus 1 bar, right? Then it gives QT minus 1 bar. So now this is the conclusion. I'll answer your question in a bit, but for now, let me conclude, okay? What I have here. So far, what I get is, so when I have 0, this guy is QT minus 1. So this is QT minus 1 bar. Did you see that? What is the meaning? So when this is 0 and this is 0, your Q remains, Q is exactly as QT minus 1. And QT minus 1 is exactly at QT bar. So what is the meaning here? What happened? When J equals 0, Q equals 0, sorry, J equals 0, K equals 0, QT equals QT minus 1, QT bar equals QT minus 1 bar. What is the meaning? Can I say this state is whole state? Can I say this is the whole state? Yes, no, maybe, kind of, not really.
Maybe.
Okay. Okay. so when J equals 0, K equals 0, right? When J equals 0, K equals 0, what did you find? QT equals QT minus 1 and QT bar equals QT minus 1 bar. So that means what? What is the meaning of this? This is your final state, right? Qt means final state. What this means? This is the initial state of this guy. This is the final state. This is the initial state. So final state equal to initial state, meaning what happened? Whatever data you have here, it remains there. Suppose you had 1 here, it will be 1 here. If it is 0 here, 0 remains there.
Gotcha. So it is a hold state.
This is a hold state. Yep, exactly. That's what I meant.
Gotcha.
All right, let's go to the next next thing now. Now, so our turn, what do we want to do? So let's do j equals 0, k equals 1. J equals 0, k equals 1. Because we have 4 states, right? 0, 0. We did 0, 0. Let's do this j 0, 1, right? This is your this is your j, this is your k, right? Okay. So now let's do this. So what happened? What is the output of this guy? This guy here. Should I write 0 or 1?
1.
1. So when one of the input of NAND gate is 0, the output is 1. So how about here? What is this guy? We don't know, right? We don't know yet. So we know the input of G1 is 1. Now let's figure out the G2 output. How do you find the G2 output? So what is here? So this is you are trying to find QT, right? Again, you are trying to find QT. So from QT minus 1, right? So from QT minus 1, you are trying to find QT. From QT minus 1 bar, you are trying to find QT, right? Then what is this guy? So here the input is the input this or that? Let me write T or T and B. Is the input T or B? Top or bottom? Here. We are trying to find this. Remember, QT is current state. QT minus 1 is the previous state, right? T means current. T minus 1 is previous. So if this is, what should be here? We are trying to find the current state based on the previous state. So what should be here? Should I write QT minus 1 or QT? See, it is coming from here, right? This guy is coming from here. This guy is that guy. So what is this? QT or QT minus 1?
QT minus 1.
QT minus 1. So that's why, what is the output here? NAND gate, right? You have 3. By the way, clock is always 1 because it works when 0 to, when it transit from 0 to 1. That's why clock is always 1. So this is always 1. This is already 1, right? And this guy is QT minus 1. So what is the NAND gate? What is the output here? The output is this. 1, 1, and QT minus 1, whole bar. That's the output. This is the output. This output here. This output is this output. Does it make sense so far?
Yep.
So then how do you simplify this guy? 1 times 1, 1. then qt minus 1 times 1 times 1, which is qt minus 1, then bar, right? So this guy is qt minus 1 bar. Does it make sense? Okay, now this is qt man. Okay. Then what is your qt then? What is your qt? So your qt is, what is the input here? To find qt, right? You need the input here. Give me the input, please.
QT minus 1 bar.
Yes, qt minus 1 bar. So what is the output then? Let's figure out this output. This output is this. So this one, right? This one is here. Then qt minus 1 bar. As you said, this is qt minus 1 bar, right? Then NAND gate gives you whole bar, right? So you have this bar here, whole bar. Then you have one qt minus 1 bar gives you qt minus 1 bar. Then bar of bar is qt minus 1. Does it make sense? So this guy is now qt minus 1. Okay. All right, so I don't need this. All right, I have found these two things here. Now, what is my qt minus bar? So let's figure out this guy. So we figure out this, we figure out this, let's figure out this now. What is this guy? Qt bar. What is the input here? What is the input to this guy? Qt minus 1 and qt minus 1 bar. Does it make sense? Qt minus 1 and qt minus 1 bar. These are the inputs to this guy. Our goal is to figure out here. So what is this guy? So NAND gate, right? This is NAND gate, right? So qt bar, meaning this guy, that's what we are trying to do. This guy equal to, you have the input here. This is one of the inputs, this is another input. So you have two inputs NANDed, meaning you have the whole bar here. Then what is this guy? What is this times this? What is A times A bar? 0. Then you have the whole bar, 0 bar. What do you get?
1.
1. See, your qt minus 1, qt bar is 1. Okay. Let me erase this. I don't need anything now. I'm happy. So I'll clean this. I already got that one. So my qt bar is 1. This guy is 1. So if this is 1, see, this is 1, right? So what is this? This was 1 also, right? Wasn't it? This is 0, right? This is 0, this is 1. That's why this is 1. So what is 1 and 1 for the NAND gate?
0.
0. So that's why this is 0. That makes sense, right? So Q is 0, Q bar is 1. Meaning when J equals 0, K equals 1, Q equals 0, Q bar equals 1. It is set or reset? Reset. Because you just look at Q. Is the Q 0? Then it is reset. Okay. Now let's change it now. Let's change it to Let's change this to something else here. So here, let's change this to j equals 1, k equals 0. J equals 1, k equals 0. Again, your clock is always 1, right? This is 1. So when k is 0, what is this guy?
1.
1, right? What is your output of G1 then? What is the output of this guy? So you have coming in from here, right? So from here, what is it? What is coming in? Qt minus 1 bar is coming in. Previous state is coming in, right? So this is coming in. You have j equals 1, and you have clock always 1, right? So this is 1, this is 1, this is 1. What do you get if you NAND all together? 1
0.
times 1 times Qt minus 1 bar, which is Qt minus 1. So you get Qt minus 1 here. Qt minus 1. Make sense?
So how would you know when to put those double bars over the equation?
Oh, because this is an AND gate.
So just because it's a NAND gate, you would put those double bars over the 1 times Qt minus 1?
Here, right here, right?
Yeah.
Okay, so let's see. Let me redo it. So how does if you have NAND gate, if you have a 3 input NAND gate, ABC, so what is the output of the NAND gate? Your Y is output, right? A, B, C. This is what you get. So in my case, what is my one? So you have the whole bar there already. So what is my A? A is 1. What is my B?
1.
1. What is my C?
Qt minus 1 bar.
Q, T minus 1 bar. So how do you simplify it? So this times this times this. You simply get Qt minus 1 bar. Then you have whole bar already. So that's why you have 2 bars. So what is bar of bar? Qt minus 1, right? What is A bar? Bar. Simply A. So that's why you have Qt minus 1. Does it make sense?
Mm-hmm.
Good. Okay, now, so this makes sense, right? So meaning my output here is GT minus 1. Now, what is Qt? Now let's figure out Qt. So what should be another input here? Qt minus 1 bar, because it's coming from here, right? So we're interested in final state based on the initial state. Interested in final state based on the initial state. That's why the input is initial state, output is final state. That's the meaning. So here, Qt minus 1 bar goes here, then Qt minus 1 is here. So what is the NAND gate again? This times this NANDed together, right? So meaning Qt minus 1 is this guy, and Qt minus 1 bar, this guy. So NANDed together, meaning you have the whole bar again. So what do you get? If you have these two together, so A times A bar. So what do you get? 0. Then you have to do the whole bar again, then 0 bar is 1. So you have 1 here. So your Qt is 1. So your Qt is, this is 1. Is this set or reset? So when Q is 1, this is set state, right? So again, so this should be 0, right? Let's see. It will happen 0. Let's see. Let's try. So it seems this is 1, this is 1, right? So what is the output here? 1, because of k equals 0 gives you 1. So 1 and 1 is 1 and 1 is 0. See, it makes sense. This is 1, this is 0. Makes sense. They're just the opposite of each other. So far, our JK flip-flop is working the way it should be working. There is no any problem, right? We got the whole state, J equals 0, K equals 0. We got set state, J equals 1, K equals 0. Now we got the reset state, J equals 0, K equals 1. Now the thing is one more thing remaining, right? Let's do that. So what happens if you have, this is very important, okay guys? Even though this is the last one, this is the most important one. Last but most important. So J equals 1, K equals 1. What happens J equals 1, K equals 1? Let's see. So when J equals 1, K equals 1. Again, clock is 0, right? This is 1. So this is 1. Clock is always 0. Because it changes from 0 to 1, then something happens. All right, so what is the input of G1? This guy. So 1 times QT minus 1 bar, right? This guy, QT minus 1 goes there. Okay, so that's what it is. Input of G1 is 1 times QT minus 1 bar. So if you multiply this together, you get QT minus 1 bar times 1, which is QT minus 1 bar. Then bar of bar is simply QT minus 1. This guy is QT minus 1. This is QT minus 1. Okay, what is the output of G2 then? This guy. So you have 1, 1, and what is this guy? QT minus 1. Okay, so meaning you have 1, 1, 1, 1, then QT minus 1. Then the bar, right? NAND gate. So what do you get? QT minus 1 bar. So this is QT minus 1 bar. Now, what do you get here? What is your QT bar then? Let's figure out QT bar. So what is this guy? What is this guy? QT minus 1. So you have QT minus 1, one of the inputs, the other input is QT minus 1 bar. Then what is here? That's what you need to figure out. So that's why you need to figure out. So QT bar, we need to figure out QT bar. Meaning one input is QT minus 1. That's the one. The other input is QT minus 1 bar. That's the other one. Then what do you have if we multiply this together? It's simply like A times A bar, which is 0. Then you have the whole bar again, then 0 bar, which is 1. So this guy is 1. Okay. Now the main thing is we are trying to find this guy now. This is our main goal. What is Q? Your main goal is to figure out Q. So this is 1, right? So what is this thing?
0.
No. See, G1. G1 is QT minus 1.
Oh, my bad.
Yeah,
yep.
Sorry, this is QT minus 1, right? This is QT minus 1. So what is the input of this guy? One is QT minus 1, the other one is 1, right? See, this is already, we figured out this is 1. So what happens if you multiply this together?
You get QT minus 1 bar.
Exactly. So your QT will be 1 times QT minus 1 bar, whole bar, then QT minus 1 bar. This guy is QT minus 1 bar. What happened here? So when I say QT minus 1 bar, what do you remember? When I say QT minus 1 bar, this is the previous state here, right? QT minus 1 bar. See, my QT equals, look at that. My QT equals QT minus 1 bar. If it were QT minus 1 simply, we call it whole, right? Do you see that? But if it is QT minus 1 bar instead, then what do you call it? You call it toggle. Meaning you are getting the output here, which is coming from the Q bar output, the previous state of the Q bar output. That state is called toggle state. That's the main beauty of this guy, this JK flip-flop. Because in JK flip-flop, 1 and 1 is not illegal anymore. Bless you.
Thank you.
In JK flip-flop, 1 and 1 is not illegal anymore. Instead, 1 and 1 is called toggle state. This is the meaning of toggle state. So QT equals QT minus 1 bar is called toggle state. Does it make sense so far? Question, please.
What does toggle state do exactly?
Oh, well, so what does it do? Okay. Sometime, so at times you might need the output. You might need the output, which is the output of Q bar in the previous state. So when you have data, you can use the data for different purposes. So we'll see that. We have a lot of application for that, okay? But the thing is, we are happy right now. Even though we don't know what it does, we're happy. You know why? Because 1 and 1 is not illegal anymore. That's why we are celebrating. We're celebrating for that. 1 and 1 is not illegal anymore. That's the big news.
Okay, thank you.
All right, so let's do the diagram here. So let's use the what do I call it? This is the summary, right? This is summary of JK flip-flop. So J equals 0, K equals 0, whole state. So J equals 1, K equals 0, set. J equals 0, K equals 1, reset. And 1 equals, 1 J equals 1 equals 1, K equals 1, then you have QT minus 1 bar. See? So your output will get QT minus 1 and also QT minus 1 bar. Okay? You can have both of these things there. QT minus 1 is hold, QT minus 1 bar is toggle. Okay, let's use this and figure out the timing output. Okay, so you are given these three things. You are given clock, J, and K. Now your goal is figure out these two. Let's figure that out. So JK flip-flop works when the transition occurs from 0 to 1, right? Keep that in mind. When the transition occurs from 0 to 1, your JK flip-flop works. So what is the transition 0 to 1 here? This is transition 1, this is transition 2, this is transition 3. Okay, let me label it. 1, this is transition 2, this is transition 3, this is transition 4, this is transition 5, transition 6, this is transition 7, this is transition 8. So let's figure out Q and Q. Let's figure out Q first, okay? Then we'll do the Q bar. Let's do Q first, then we'll do this later. So what is your Q when clock, right here, when clock goes from 0 to 1, then what is your J and K? J is 0, K is 0, right? Then what is that called? That's called hold state, right? Meaning, if you had Q equals 0 here in the beginning, then it stays 0 until you see the second clock, right? The second one, until you see the second one here, second trigger, right? So this will stay low. At this point, what happens? Let's see. At this point, what is your J?
1,
J is 1, K is?
0,
So 1 and 0. When 1 and 0, what is your state? Set, means 1. That's why from 2 to 3, you get 1. Then right here at 3, location 3, what is your J?
1,
What is your K?
1,
So when is K is 1, 1, then what happens?
toggle.
Toggle. Okay, now to understand toggle, we have to do the Q bar also, okay? So where are we? We are right here, right? We're right here. So to understand toggle, let's do the Q bar, because toggle comes from where? See? From the bar side, right? That's why you have to understand Q bar. So in the Q bar instead, in the Q bar, when J equals J equals 0, J equals 0, K equals 0. If Q is low, Q bar is high, right? There is no doubt about it. You can simply, if Q is 0 up to here, your Q bar is high up to here. This is the complement, right? So then here Q is low, sorry, high, then your Q bar is low. You understand?
Yep.
So now the thing is right at this 3, right? Point 3. At point 3, your J is equals 1, K is equals 1. So you have 1 and 1, toggle. So meaning what happens is, so this Q will be toggle, meaning it will be exactly same as the previous state of Q prime. That's the meaning of toggle. Meaning, what is the previous state of, previous state of Q prime? This is the previous state of Q, right?
Mm-hmm.
So what is the previous state of Q prime? Low. Previous state of Q is high, previous state of Q prime is low. That's why this low goes in here. Do you see that? Toggle, see? This goes in here. It toggled. So that's why, since this is low, this is low. That's called toggle. Just one step behind. You just go one step behind in the Q bar side. Okay, because this is your Q bar T minus 1. In the go to the Q bar side, one step behind QT minus 1. Not QT minus 2. You cannot go 2 steps behind. Just 1 step behind. Just before it. What is the QT bar just before it? This is the point you are talking about. Just before it. What is your QT minus 1? What is your Q bar? Just before it, your QT minus QT bar is this guy, which is low. That's why the low goes in here. Does it make sense?
Mm-hmm.
So then this is low. Now I'll go Q and Q bar side by side, okay? This is low. Then what is this guy? Obviously this should be high, right? They are complementing to each other. Then let's go to number 4. Guys, this timing diagram is very important. It will be in your test also, okay? After finishing chapter 5, we'll have the midterm test. So right at this point, what is your J? 1. What is your K? 1. Again, you have the toggle state. Again, you have the toggle state, 1 and 1 toggle. So what does this mean? So right at this point, you have toggle, meaning look at the previous state of Q bar. Go here. What is the previous state of Q bar? Low or high?
High.
High. That's why you get high here. Makes sense?
Yeah.
So this guy goes in here. Toggle. That's the meaning of toggle. So this is done. Now this is toggle, meaning this is high, and definitely this is low, right? This is Q bar is low. Now we go to number 5 here. Number 5, J is low or high?
Low.
This is low. So low and low, what happens? So yeah, so low and low is hold, right? Hold meaning whatever you have previous. Previous is what is previous here? High. That's why it holds, means remains high. Now we are right here now. We are right here. J equals 0, K equals 0. What is this again? Again hold, meaning whatever you have here stays here, which is high again. So this everything here is high, that's why everything here is low. Q bar, right? So we have no problem so far. Then, okay, now where are we? We're at number 7, right? Number 7, you have high, you have high. High and high. You have toggle, right? So right here, you see the toggle, meaning right before it, what is on the Q bar side? Low. Okay. You see low here, that's why this guy goes in here. This goes in here, meaning this low becomes this low here. That's the meaning of toggle. See, this is low, this is high, because this is called Q bar, right? Q bar is high. Now, where are we? We are at here, right? This point. This is high, this is high. So high and high, again toggle, right?
Mm-hmm.
Meaning, what do you have here? Toggle meaning, so you have, this goes in here. This guy goes in here. That's the meaning of toggle. If this is low, this is high. That's how it works. So this will be in the test. This kind of problem will be tested in the midterm. You have to understand this clearly. This is called timing diagram, by the way. Question here, please. I think we call it toggle. You know why? So this is the toggle point, right? So this is toggle point because you have a high here, you get low, you toggle, right? So this is also toggle, right? So you have high here, the high becomes low. That's the toggle, right? That's why I think they call it toggle.
Perhaps I just wasn't noticing, but does the clock really have any, does it really do anything?
Oh, is the clock doing anything? Okay, you know what clock is doing? The clock is telling you when to transfer your data. So this tells you when to work. The clock tells you what time you should work. You don't have to work all the time. You have to just work whenever I go from low to high.
Oh, okay. Thank you.
Let's do one more problem because this will be in the test. So I wanna focus on, I wanna make sure you guys understand it. Let's do one more. this time you might need your help, okay, please? So you have C and C is the clock, and you have J and K. So let's do it. Let's do the Q only here, okay? So this is your 1, this is your 2, this is your 3, this is your 4, this is your 5, this is your 6, right? At point 1, what is your J? 0. K 0, right? Then when J equals 0, K equals 0, what do you get? No change, right? So your Q was 0, it stays 0. Oh, I forgot one. Did I forget?
So if the clock is
Oh,
determined-
negative trigger. Yeah, this is the negative trigger, I think. Let's see, negative trigger. I think I made a mistake here. Determine the Q output for the negative edge trigger, okay? Sorry. And what is the question again?
if the clock is determining when you do your calculations, right in the beginning of C and J, you'll see that J turns high halfway through the clock, like up cycle.
Yeah,
So like what causes that delay?
okay, hold on a second. I think I made a mistake here, okay? Let me delete it. So Austin, this is so negative edge, okay? This is the negative edge, by the way, okay? So I should have made here negative edge. See, the previous one was positive edge. Now here negative edge. Now I corrected my picture. Austin, does that answer your question?
Well, actually, so like still like even though like you have like the down or it going to low on the clock after J switches. So like what causes it to switch in the middle of the clock tick, I guess you can call it.
Okay, C, J, and K, I don't have control. It's given, okay? C, J, and K is given. So my goal is to figure out Q. You cannot answer here. You cannot question these three things, okay? Because this is given.
Okay, so it's just okay, I get it now.
Okay, this is the question, okay? So this is question, now your goal is Q.
Okay.
All right, so this is the negative edge trigger. That's why whatever happens, happens right at this point. So at this point, what is your J, what is your K? 0, 0. So meaning no change, right? So you had 0 here. That's why at this point, no change, meaning remains 0 until this point. Right at this point, then another thing happens. This is number 1, this is number 2, this is number 3, this is number 4, this is number 5, this is 6. So at point 2, this is your, help me, 1, this is your 0.
So it's
So that's
set.
1 and 0 is set, meaning you get 1, right? So that's why we have 1 here, okay? Then it will remain 1 until third trigger right here, up to here, right? So that's why where the third trigger is. See, this is the third trigger. Oops. Up to third trigger, it remains high. Now let's talk about third trigger right here. At third trigger, what is your J and K?
0, 0.
0, 0. Meaning, what is 0, 0?
Hold.
Hold state. Hold meaning, whatever you have in the right before it, it will stay the same. Right before it is high. That's why it will stay high up to trigger 4. So right trigger 4 now. What? Oops. Trigger 4, what will happen? What is your J?
0,
What is your K?
1.
What is that one? So 0, 1, right? What is 0, 1? 0. right? Reset, meaning now from here it go to reset, meaning 0. And from here to here is 5. Okay, so we are right here. So at 5, what is your J? 1, K is 1, right? So when J equals 1, K equals 1, what do you get?
Toggle.
Toggle. Toggle meaning what? So toggle, right here it happens, toggle is happening, right? So this is Q, Q bar will be, if Q is low, Q bar will be high, right? So this will be high here, this high goes in here, toggle. Okay, so this is high. From here to here, toggle, this is high. Now we are doing at 6. 6, so we have high, high and low, right? 1 and 0. So 1 and 0 is set state. That's why we have 1 here. Question here? Question, comment? Am I good to go?
Yeah.
Yeah.
Very good. Now let's do the T flip-flop, okay? Now we finish the JK. So we already started with JK and T flip-flop. So your JK is done. Let's do the T now. So T is very easy. So if we have the JK flip-flop, then tie this J and K together. Okay, so then becomes it T. Okay, so T equals J or K. If T is 1, J is 1, K is 1. If T is 0, J is 0, K equals 0. So you basically will have two function in the JK. One is for 0, 0, 0, the other one for 1, 1. So meaning the T flip-flop just works, it has just two action. One, no change, the other one, toggle. No change, toggle, no change, toggle, okay? So set and reset is for, doesn't happen here. Because,
You made it look like Jork.
excuse me?
I was just making a joke, sorry. Continue.
Okay, so this is the truth table for T flip-flop. So T equals 0, no change. T equals 1, toggle, okay? That's the T flip-flop. And this is the diagram for the T flip-flop. So now can you tell me if this positive trigger or negative trigger based on this? Look at this picture and tell me. Can you please help me here? Is this negative trigger or positive trigger?
Would it be positive since it doesn't have the circles?
Yep. Yep. Thank you. Now let's do the latch or register. Okay. So register mainly, we're talking about register now. Okay. So register is group of flip-flops. So here, let's see. Let's look at the picture here. You have how many flip-flops are here? We have one flip-flop. You know what? Let me pull this aside. So you have how many flip-flops here? You have one flip-flop. Okay, there is another flip-flop. I have 4 in here, right? I have 4 flip-flops. And these are, in this case, I chose D flip-flop, okay? So D flip-flop, that's why. This is my D input, and I have to give this is my D input here. This is my D, right? This is my D. I call it D, 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 D. So then I give them the clock, right? Clock pulse, positive, clock pulse, right? So I'll give the clock pulse from here. So this is the clock pulse they are getting from this line. See, they're getting the clock pulse from this line. I call it CLK. So all the flip-flops are getting the pulse from this line. Okay. Then your D input is coming from here. You are giving the D output input here. You are giving the D input here. You are giving the D input here. You are giving the D input here. Okay. Then also you are getting the output, right? Your output goes from here. Output goes from here. Output goes from here. Output goes from here. So let me call this D0. This is D1, D2. This is D3. This is Q0 output, right? Q1. This is Q2. This is Q3. Okay, so by the way, this is called CP, right? Or clock pulse. CP, CP, CP. So let me call this flip-flop. This is the output Q0. Yeah, so this is Q0. This is Q0. This is your Q1. This is your Q2. This is your Q3. So how many is flip-flop we have? So we have 4 flip-flops, right? So 1, 2, 3, 4. Okay. So if I draw nicely, then this looks like this. Okay. All right. So this is called register. Okay, register is the group of flip-flops, each one of which shares the common clock and is capable of storing 1 bit of information. So they share common clock. They share the common clock and capable of storing 1 bit of information. So this guy can store 1 bit. This can store 1 bit. This can store 1 bit. This can store 1 bit. So it could be 0, 1, I don't know. This is 0, this is 0, I don't know. This is 1. I don't know, right? In addition to flip-flops, a register may also have combinational gates that perform certain processing tasks also, okay? So, but it's not shown here. So, in this case, what is the trigger? Is it the positive trigger or negative trigger in this picture? So this is positive trigger, right? At the positive trigger, what happens is the data transfers from input to output. Okay, so suppose this is 1, this 1 goes to output. Suppose this is 0, this 0 goes to output. Suppose this is 0, the 0 goes to output. Suppose this is 1, this 1 goes to output. At the positive trigger, the binary data transfer from input to output. Okay. Okay, so what is this 1, 1, 0, 0, 1? So these ones are the value immediately before the clock is. Okay, immediately before the clock is. What is the immediately before the clock is? That data will transfer to output. That's how a register works. Okay, a register transfer the data immediately before the clock age. Okay, so we'll see that in the next slide. So how does it do? So this type of latch is called, this kind of register is used in computer processor. Okay, for storing binary numbers and codes. Okay, let's see how it works. Let's see how the register works. So what did I say? So it transfer the value after the clock age Let me write this down. This is very important. The value after the clock is value or output. Output after the trigger equal to input immediately before the trigger. This is the rule, okay? This is how the register works before the trigger. Let's use that rule and finish this, okay? So now you are given clock, you are given D3, D2, D1, and D0. So there is no question, okay? Now your goal is to figure out these four. Let's figure this out. Once you figure this out, I'm done for the day, okay? So let's do it quickly. So they work, they are positive, right? See, these all are positive. So based on the picture, we can say this is positive edge trigger, flip-flop. That's why we just worry about the positive edge here. This is number 1, positive, 0 to 1. This is number 2, 0 to 1. This is number 3, 0 to 1. This is 4th, this is 5th, 0 to 1. Okay, so we don't have to worry about Q3 until this, because if it is 0, remains 0. Okay, Q2, if it is 0, remains 0. Q1 remains 0. Q0 remains 0. Until this point, we have no problem, okay? Right at this point, now we have to figure out all those four. So what is your D3 here?
1.
D3, no, we don't worry about, okay. Right before the trigger, this is the trigger, right? Right before the trigger, what is D3? See? 1, right? Right before is 1. That's why your D3, we're talking about D3 and Q3, okay? D3 and Q3. Right before the trigger, D3 is 1. That's why right after the trigger, your Q3 is 1. See the logic?
Mm-hmm.
Because right before the trigger, your D3 is 1. Right after the trigger, your Q3 is 1. This is how the register works. So similarly, how about this guy here? This guy comes from D2. This guy comes from D2. Right before the trigger, this is the trigger location, right? What is D2?
0.
0. That's why right after the trigger, your Q2 remains slow. How about here? Right before the trigger, your D2 is high. So D1 is high. That's why right after the trigger, your Q1 is high. Okay, now we have to go to D0 here. Right before the trigger, your D0 is low. Okay, right after the trigger, your Q0 is low. Now this is done. Let's do the number 2. Right before the trigger, your D3 is low. That's why right after the trigger, your Q3 is low. Right before the trigger, your D2 is high. That's why right after the trigger, your Q2 is high. Right before the trigger, your key D1 is high. That's why right after the trigger, your Q1 is high. Right before the trigger, your D0 is low. That's why right after the trigger, your Q0 is low. This one goes on and on and on, okay? This is how the register works. Question here?
Yeah.
All right. If you don't have any question, I am done for the day.
Bye.
Have a
Bye-bye.
good day.